All right, we're going to look at section 1-2, which is measuring and constructing segments. And we talked in 1-1 what a segment was. We also have some new terminology here. So what we're going to look at is these what are called postulates and axioms. So a postulate or an axiom, I'll refer to these. Postulates are just rules that are accepted without proof. So for example, let's say I have point A and I have point B. And so a postulate that you probably have heard multiple times, especially when someone talks about geometry, is the shortest distance between 2 points. So here's 2 points. The shortest distance is a straight line. So like from here to here, straight line is the shortest distance between those 2 points. What that means is if I was going from point A to point B, if I walked all the way over here, that's not the shortest distance, right? The straight line is the shortest distance. And so that's what a postulate is. And so when we say that, everybody's like, well, yeah, that makes sense. There's no reason to debate that or argue that. And so you don't have to provide proof for that because that makes sense. Now, one you learned in Algebra 1 last year was the Pythagorean theorem that says a squared plus b squared equals c squared. And then Pythagoras had to prove that that was true. And so he had to provide evidence and give support for that. And so that is going to be a theorem. That's why it's called the Pythagorean theorem. And so we'll talk about some theorems later on, but what we're going to look at in this chapter is just postulates. So the first postulate we're going to look at is called the segment addition postulate. I love the name of all theorems and postulates in geometry because they're very literal. So obviously we're going to be talking about segments. We're going to talk about adding them. And so we're going to say what's true, because this is assumed true, about segments when I add them together. That's the segment addition postulate. Now, most postulates are written out in a very long, wordy form. Anytime that I can, I will concise those down. Or make them more concise. I don't think that's correct terminology, to either a formula or a picture. So in this case right here, this formula is going to go with this picture down here. So if I have this line segment, I've got point A, point B, and point C. What this says, let's say this is 4 and this is 7, then 4 plus 7 equals 11, which means that the length of this whole line is 11. Pretty obvious, right? Like that's stuff that we know. That's why it's a postulate. No one had to prove it. We're like, well, yeah, that's true. So that's what the segment addition postulate is. So we're going to look at some examples. Let me clear my ink. Clear it. And then let me, oops, mouse. Okay. So I'll get my rest of my stuff up here. Okay. So let's look at this together. So I've got this segment up here, segment RT, and within RT, I have two other segments. So I've got from R to S, that's going to be one segment. So I'm going to try and trace that. And then let me change colors. So from S to T, that's another segment. And so then the purple segment plus the green segment equals the whole segment, which is RT. So that's what that's referring to. All right, so let's look at number 1. I have ST is 15. So this segment up here is 15. And then RT, so this time they didn't give me RS. They're telling me this whole thing right here is 40. I want to find this segment. Okay. Now, most of you will just do this in your head or your calculator, and I'm fine with that. However, I'm going to go ahead and write down what the rule is or why this is true or what we would do algebraically. I don't necessarily expect you to do that, but I'm going to show it to you so you understand what the thinking is here. So since this is an unknown, we don't know what RS is, we're going to call that X. So I have X plus 15 equals 40. It's just an equation. Okay, and so then we would subtract 15 from both sides, and so then X is equal to 25. So, oops, find my mouse. Okay, oh. Now here's what I was going to tell you, and I said when we were doing this in the part where we were reviewing equations, I told you I'm okay with you skipping steps. Like I know when you were in Algebra 1, you had to show all of your work, and that was necessary for Algebra 1. But now I'm your geometry teacher, and your geometry teacher needs to know that you understand the postulate. So if you have this written down, okay, I'm not requiring you to write this, but let's say you write that down, and we get going fast sometimes, and say I mess up and I say 35 instead of 25, or I say 15. I mean, we're just working really fast, and our brain gets a little glitchy sometimes. But if you have this written down, I'm going to give you half of the points. So say this was like a 4-point question, and you just did the math really fast in your head, and you messed up, and you don't have any work. You miss all 4 points because I don't know what you thought, what your thought process was. However, if you write this down, then I go, you know what? They understand the segment addition postulate. So the geometry teacher in me is like, yes, that's worth 2 points. Now they messed up on their algebra. They were just going fast. And then I would take off 2 points for that part. So it's always best to write something like this yellow circle down for me, because in the long run, that's going to be helping you with points, even if you already know how to do it and you can do it in your head, which I know y'all can. Just want to be sure that we are all on the same page. All right, so let's look. Let me move this out of the way. So let's look at the second question. So you'll notice it got a little more complicated because now we've got some algebra here. And again, this is while we were practicing our algebra. So RS, this purple segment, is 8y plus 4. This green segment right here is 4y plus 8. And then the whole thing is 15y minus 9. So what I'm going to do, I don't know what color I am here. Let's change. Okay, what I'm going to do is 8y plus 4, that's segment RS, plus ST, 4y plus 8. All of that equals 15y minus 9. So this looks very much like what we were reviewing at the very beginning of the week. Okay, so Dad can pick chocolate muffins. There is no distribution. There is cleanup. So I'm going to clean up this and this together. So that's 12y plus 12 equals 15y minus 9. I am going to pick on the little guy because there is a little guy. So I'm going to subtract 12y from both sides. So I have 12 is equal to 3y minus 9. Now I'm ready to move the constant. So that's plus 9 plus 9. I'm running out of space here. So 21 equals 3y, and then I divide both sides by 3, and so y is equal to 7. Now, all of these steps here, you don't have to write them for me, okay? But like we talked about up here, if you get this written down, you're going to get half the points because you've shown me you understand the segment addition postulate. And then if you mess up down here in your algebra, I may take off a point or two, just depending on how much you show me. But if you go from here straight to the answer, you're probably only going to get half the points if you don't get it right. But if I see that you did something, something wrong here or something like that, it's subtracted instead of added, then I can just take off a point. So the more stuff you show me, the better off you're going to be as far as points are concerned. Okay. I think that is the end of this slide. Let me make sure, because I think it goes to, yeah, okay. So we are done with 1, 2.